Hello everybody, welcome to the OpenValue meetup. Welcome to everybody here in the office, also warm welcome to everybody in the stream. We have two talks for you tonight, and I'm going to introduce the first one to you. It's about gRPC, and it's one of my favorite interview questions. If I talk to an engineer, do you know what gRPC is? And most don't. So these guys are not going to explain, I think, what gRPC is, because they are going into an advanced scenario, cross-language gRPC apps. So this is going to be really interesting, I think. It's going to be helped by two engineers that I hold in high esteem. Trietsch, senior software engineer at Stream Privacy, and Jan-Kees van Andel, software architect at JPoint. And I'm really curious to hear what you guys are going to tell. So take it away. Thank you.
All right. Thanks. Thanks all for joining our talk about cross-language gRPC applications. We're here to tell you about the learnings we have while using gRPC in production for over a year. My name is Trietsch. I'm gathered with Jan-Kees van Andel here, and we work for Stream Privacy. So let's first start off what gRPC actually is. gRPC is a remote procedure call framework, and important, it doesn't represent, it's made by Google, but the abbreviation is not Google Remote Procedure Call. It's actually gRPC Remote Procedure Call, so it's a recursive acronym, like PHP, as I've been told by Jan-Kees. It extends protocol buffers, and it has cross-language support there, because protocol buffers can be generated into various languages. From the top of my head, I believe over 10 at the moment. And it's high performance, and it's HTTP2 based. So it's meant as transport between a client and server. Why did we choose gRPC? Well, first of all, we have microservices architecture, and we have a lot of applications that communicate with each other, and a shared API definition that all the application use was very convenient for us, for the applications to communicate with each other. Next to that, OpenAPI was also a hassle for us, because the OpenAPI specification was included in every repository of every application. And not only did that mean that different applications communicating with each other needed each other's OpenAPI specifications, but also in the repositories themselves, when you develop for the application, it was possible to have a discrepancy between the Swagger, the generated Swagger page, and the actual implementation of your server. I had a lot of times I had the issue that I was using the Swagger page to do a specific REST call on my application that I was developing, and that that it just didn't work. And after a few minutes, I discovered that there was a misalignment there. So OpenAPI was a hassle for us and was error prone. Next to that, we have quite some different languages that we use, a lot of different clients well, our services, our backend services are using the JVM, so that's Java or Kotlin. But we also have a Python client, we have a CLI written in Go, and we have a web application that uses TypeScript. So that was another reason for us to actually choose gRPC. But before we move on to gRPC, I first need to give an introduction about protocol buffers. Like I mentioned, gRPC uses protocol buffers. So it's often called protobuf, and protocol buffers are language agnostic, allow you to define a message specification in a DSL, which can be compiled with a proto compiler into various languages, into for example, for the JVM, it's generated into class files, which you can actually use to build up these messages. Next to that, protocol buffers have a high emphasis on backward and forward compatibility. So this ensures that changes that you make are compatible with the current state. The serialized data that actually is transported over the wire doesn't include the schema, so it's actually only binary and binary data. In comparison with JSON, where you actually send the entire schema every time you send a message. And the serialization is very fast. Let's move on to a proto definition. Here you can see a full proto file, and I'll go through it step by step. So at the top, you see the language version that we use. And here you see that we use Proto 3. At the moment, there's Proto 2 and Proto 3. And Proto 3 is actually, most of the examples that you see on the internet are using Proto language 3. And there have been some changes in comparison with Proto 2, but I won't dive into these details here because they are quite quite sophisticated, the changes that were made. The next part is the package, and you can compare this with the package for JVM applications. This is just a grouping under which you can put all your proto files. And this is actually also reflected in the code that's generated for every language. And here, the next part that we see, we have a message called meetup, and meetup has two fields, of which the first one is name, and you see the type on the left-hand side, which is string here, and you also see the order of the field. So this is the first field, and this is important in with protobuf, because when you serialize a message, when you send it over the wire, no schema is included, like I said, in the data that's being sent. So the order of these fields determines how the message is serialized and deserialized. The second field that we have over here is also a string, but it's repeated. This means that it's when code is generated, a collection will be used. For example, in the JVM, this will be a list, for example. Okay, what happens if we use this file and use the proto compiler to compile it to Java code? So we use a proto compiler here. We specify the file, and we specify that we want Java code and the directory that it needs to be generated to. So we generated it, and if we do a tree of that directory, then you see the entire package structure is reflected over there. And if you recall, the file was named proto_example.proto. That's also reflected in the Java file name over here. When we take a look at the line count, you see that it's 836 lines, and that's quite a bit of code for this small proto file. And if you look at the code, Jan-Kees will show it in the demo, but if you look at the code, it's hard to read. But you rarely have to read that because you have your original proto files that you can read, which are way more convenient to read. Let's take a look at the generated Java code. Here you can see that we actually use a builder construct that is included in the generated code to make up actually a proto example.meetup message in this case. We set the name, and as you can see, we can provide a list, a collection here to the all speakers field, or to the speakers field. And we provide Jan-Kees and Robin here as the speakers. So what happens if we write the message to a byte array and we print it? Well, we'll see that in the next slide. And the last bit here actually is that we read the byte array back into a meetup message. So we parse it again from bytes. So we serialize it and deserialize it again. Well, the output, you can see the byte array, and you can see that we can actually read it back. So this might look like a bit of a silly example, but that's actually what happens when you send something from a client to a server. The client serializes it, and the server actually deserializes it back. So let's compare it to JSON. Here you see we have an equivalent JSON where we include the schema because that's how JSON works. And if you compare it, it's not a lot of difference here, but the bytes of protobuf are a bit smaller here. And of course, the benefits that you gain with larger messages are of course bigger. So a proto message can contain various types. We already saw some of them, for example, string, but they can also contain other scalar types, so like int, double, float, boolean. And we also have enums, repeated fields we also saw already. You can have messages inside other messages, so that's a nested construct. Map arbitrary key values. And one-offs. It's similar to what JSON schema has, but it's mutually exclusive here. So either of the two is filled in a proto message. And one important thing which is really useful with proto files is that you can import other messages and other definitions. We use a lot of these imports from Google. Google has a common protos library that they provide with, for example, a timestamp definition that you can use. This is really useful because you don't have to reinvent the wheel. One important remark about generated code and is about default values, because generated code has default values if unset. This is one of the reasons or one of the causes when moving from Proto 2 to Proto 3. This bit us well multiple times already, and you really have to think about it. So let me give the examples over here. So for example, for a string, the default value, if you don't set it in a message and transport it over the wire and deserialize it again, well, is an empty string, and you have to deal with that. And an empty string is something different than a null, the absence of a string. So you really have to think about that. But there are several solutions for that, and I can happily explain them at the end, but they're not included in this talk. Well, moving on to gRPC, we now have the introduction for protocol buffers. And we can take a look at an example gRPC proto definition. So again, we have a similar proto file like we had, but now, as you can see, we have a hello world service here. Inside the hello world service, we can define an RPC, so a remote procedure call named say hello. It takes a meetup request and returns a meetup response. And as you can see, we define the messages like we did in the original proto file without the gRPC service. And they are quite similar. So I renamed the meetup message to meetup request here, and we have a meetup response. So it's quite straightforward to read, actually. One more thing about transport and wire format for gRPC. Of course, there is a translation between HTTP and gRPC. And gRPC actually just uses HTTP and extends it. And the content type that's being used is application gRPC. So that's the header that you will see if you inspect it. And there are some other headers that are also included, of which these two are included, gRPC message and gRPC status. Status indicating whether the response was correct or something went wrong, and the message detailing what went wrong in case the status is non-zero. That brings me to exception handling or error handling. That's actually out of the box with gRPC, the code that you generate. Client and server handle exceptions correctly. So if an exception is thrown in a server application, a client will receive the exception and will correctly parse it, because it will receive a message, gRPC message in the HTTP header that what went wrong, and a gRPC status of that is non-zero. Then one more thing, if you want to include custom headers like you do with REST, then you can use gRPC metadata. And gRPC metadata actually maps onto HTTP headers. That brings me to the demo. Jan-Kees, take it away.
Yeah, thanks. Yeah, so Robin gave you a theoretical introduction, right, with some code, explained some concepts, and well, it's time for me to dive into the code then. So let's switch to the IDE. Let's go to the correct one, which is this one. Is this readable? I think it is, right? So let's see. We have a source directory and over main proto. So over here we have the protocol definition, which is more or less the same as what Robin showed already. I have 4 RPCs over here, so again a bit of theory, but gRPC has 4 types of messaging, 4 messaging modes. The first one is what Robin already showed you. It's just basic, a request has 1 response. They call it unary RPC, comparable to a function call in Java, for example, where you say I pass in a string and I get back a string. Based on that, you have something that builds on top of that, where you can send a stream of data, well, comparable to an observable or whatever in programming. Basically saying I open a connection, I send a couple of requests, and at some point I'm done sending requests, and then I get back a response. The same applies to response streaming. Well, it's more or less the same, I guess. I send 1 request and I get back a whole list of, or a stream of messages. For example, let's say you use polling now to see the status of some resource, right? Polling it to see whether it's become active or something like that. Well, you can use response streaming for that. And then you have a combination of both, which is bidirectional streaming. We don't use that. I find it really hard to come up with a good use case to do so, to use this. They typically say a chat app is the reason to do it, but you can also combine 2 others, and I think that's easier, but it's there. Basically, you have like the matrix of 4 options, like streaming versus non-streaming, on the response and on the request. I'm also not going to show all of them. I'm going to show the first one and the response streaming, I believe. Yeah, and as a note, the request is really simple. It's just a string name, and we get back a string with a message saying hello person. So let's see. First step is that we need to compile all this proto stuff to Java code or to Kotlin code. Actually, we're going to compile both of them. I'm going to just quickly glance over the Gradle file because it's quite a bit of a, yeah, it's a lot of boilerplate, but yeah, that's what you need. But basically, you're invoking the protocol buffers compiler to generate a lot of code. And if you use Gradle, then, well, or if you use Java, I have to say, then this is the Gradle way to do it. Can't really properly show it. Well, I can. Yeah, I can. I think it's over here in generated source gRPC. And then, I mean, Robin promised you to show the code, so I'm going to do that. Is this the one? No, it's not the one. This is the one. So here we have the hello world request, which only contains 1 string, right? And then you get all this stuff. A lot of very smart stuff is in here regarding serialization, handling all kinds of backward and forward compatibility issues. The default value stuff is in there. A lot of stuff is in there. Actually writing it to binary, to a byte stream, reading it back. It's all in there. But it's almost unreadable. But I suppose it's good. So don't look at it too much. Well, this is all added as generated sources, so I can use my handy code completion now. So there we are. And then we can go to the code. In this demo, there are 2 apps, a server app and a client app. Both of them are, well, let's call it a microservice, where, well, one exposes a service and the other one uses it. Starting with the server, I think that makes the most sense. It's really simple to implement a gRPC service. This is the first one. All you need to do is extend a generate base class which has been generated by the proto compiler and the gRPC plugin in there. It already contains empty implementations of all the RPCs. So all you need to do is just override it with an implementation that actually does something, which I do over here. Well, this one takes request. I take the name from the request. It's just a property I can use. And I wrap it in a response object and I pass it back. The other one, the response streaming thing, it uses coroutines. The other one also does it, but you can't really see it in the code, but over here you can, looking at the flow. What it does, it takes the name from the request and basically takes every character and with a delay of 1 second sends back character one at a time. A bit of a silly example, but at least to show the idea of streaming. Small thing to note here is that this uses the Kotlin DSL. I didn't commit the code. Cool. Let's just fix that. This one uses the Java DSL now, or the Java builder. So that's a hello world request. New builder dot set name. Oh, I need to set the response. Sorry. Set message. Capital H, because I'm not using Kotlin here. Set message. Hello. Request. Name. Live coding here. What can go wrong? Build. And then you can see the difference between the two. Kotlin DSL might be a little bit cleaner, but the difference is not night and day if you ask me. It also comes with a little bit of downsides, let's call it that. Not going into that at this point, but if you really want to know, ask a question later. So these are the things that we have in our server implementation now. Just a hello world in two flavors. Then we need to really start exposing this stuff. So it's just a main app. gRPC provides us with a server builder. Well, you can basically read what it does. Start the server, start it on a port, which is the default gRPC port in this case. Add the service, add another one I'm going to cover a little bit later. Press build and start and wait until basically the server ends. So this should work, I think, after my modifications. Yeah, they'll probably go wrong. At least at compiling and installing updates and stuff. So. No, it's running. No logging because we don't need that. I can already test some stuff now. The next thing is something just nice to tell. gRPC has quite a rich ecosystem of tools already available. I mean, HTTP is way bigger, of course. But also for gRPC, you have a lot of tools. And one of the tools that we use quite often is a command line tool called Evans. You can compare a little bit to curl, except that it's different, and it's for gRPC. So I can say Evans -r REPL. I want to have a REPL, and then I have like a semi-graphical user interface to my gRPC server, and I can say like, okay, give me the package, set the package, which is this one. Set the service, that's a demo service, and then call an RPC, call with double L. Hello world, my name is Jan-Kees, and I get back a response. Really simple, really quick, nothing needed to be set up. Except for one thing, because how does it know which packages there are and which services there are and what properties to set on the message and all stuff like that. What you need to do is enable reflection. And reflection is not exactly the same as in programming, but basically you expose the interface definition or the proto definition for use by third-party tools. Still not a replacement for compiling actually to Kotlin code or something like that, because you don't get the code completion, stuff like that in your IDE. But for a tool like this, it's really handy to have, and it's just a one-liner. You just enable it and it automatically works. Sound like a salesman now. So let's move on. Move on to a Kotlin client now. So yeah, this is like another microservice that evokes our our server. Also really simple, I think. We need to create a connection, which is something they call a channel. I connect with localhost, I connect with the port that my server is listening to. In this case, I don't use SSL or TLS, just plain text. I press build, and well, we have a channel, cool. I instantiate a stub, which has also been generated by the gRPC compiler. Pass in the, that went a bit wrong, pass in the channel. This should be better. Pass in the channel, and then I have a client which I can actually invoke. That was line 2. And I can just say, hello world. Pass in the, I told you I had 2 examples, Kotlin and Java. This is where I did it. And then I pass in a request, which I need to construct. Looks a bit clunky maybe, but the gRPC part I think is pretty clean, doesn't require much setup. Get back a response. It's in this case it's a coroutine step, which I run in a global coroutine. So it looks blocking, it's not. And over here the response thing is basically the same, except that I don't get back a string, but I get back a stream which contains strings. So over here I basically loop over them. At home this all worked, so I guess it will also work here. And then with a bit of a delay, it also prints Robin. Mandatory wait time. So there we go. So that's basically how easy it is to set this stuff all up. Apart from the Gradle stuff then. Are there any questions about this part until now? Stuff that's unclear, weird? No? Cool, let's continue then, because I have another demo. A demo which, let's first check if my server's still running. Yeah, it is. Which is a web app, because you can also use gRPC from your browser to, what in our case, an API gateway, but yeah, to your server. Well, as Robin told you, gRPC supports many programming languages and platforms. And gRPC Web is basically what it says, the web variant of it. Copy-pasted the proto file here just to make it easier to read when I'm in this window. But normally you would like put that stuff centrally somewhere. Added a small script, how to compile it. It's the same thing as that Robin already showed, but in this case I don't do Java out, but I do JS out. And being front-end, JS needs a couple of settings. So in this case I generate CommonJS, and for gRPC I generate CommonJS, and it also has support to generate TypeScript definitions. And it goes to the source/proto-gen directory. So let's do that. Correct directory? Yeah, it is. So let's go to proto, not C, proto/compile. Should work, and it does, cool. Nobody believes me because it was already there, I suppose, but basically what it does is generate, again, a lot of code, but it works, and it handles all the stuff that we wanted to handle. So all the compatibility and the serialization is all in here. And also you can see that there are some TypeScript files generated. So what does it look like? Made a small application. Not very interesting, I suppose, from a React perspective. I see that the directory has changed in my last version, so let's make this proto. I make a client, which is based on promises in this case, connected to localhost 8080, don't ask. And here you can see the code how to invoke the RPC itself. So we have to create a request, set a name, invoke it, and then we get back a promise with the response or with an error. All pretty simple, I guess. Let's run it. I hope it works after my last change. Where I just said don't ask, I'm still going to tell you now, while waiting for the server. Port 8080, that's actually an envoy listening to it. Because we do cross-origin calls from our NPM Webpack server to a gRPC backend, well, we get cost because it's a different domain, or it's a different port actually. This way, yeah. it's a different port. So course headers are sent. The gRPC default server doesn't handle course, or actually it doesn't even handle HTTP1. So we needed to have like a proxy before that to handle these requests for us. So there's just a simple envoy configuration for that. I don't think that's really a downside, because in production, you're typically not exposing your Java app directly to the internet. So I think that's okay. See, the server has been started. There we are. Robin is here. Invoke it. Hello, Robin. That's my abbreviation. All simple. Nothing fancy in this case, but just to show you how easy it is to get started with gRPC. Questions about this part? Cool, let's continue then. So basically we covered quite some ground already, giving an introduction about what this really is and how it works. So now we're going to talk about what Roy already said we were going to talk about, which is how we use gRPC. So time to deliver this promise. We made some choices in the, let's go back, we made some choices in the company to, which might look a bit weird when you first see them, but actually which worked out quite good for us. So we're here now to promote these choices and basically persuade you to make the same choices, or at least, well, convince you to that this really works. One of these is that we're really strict on backwards compatibility, saying we don't allow backwards incompatible changes. What does that mean? Adding a field is typically safe. Removal of a field is not safe, so we don't allow it. Renaming of a field is not allowed. A lot of things are not allowed. So how do you get real work done then? Well, you just have to release a new version. So you just have to set a next proto file next to the original one, a v2 or a v3 or whatever. And that will be your new version then, and the old version will still be there. And at some point you might say, okay, this one is deprecated and I'm actually going to remove it, but that's a choice you then make asynchronously. But it's an easy statement to make. So how do you do that? Making no backwards incompatible changes, because it can be really tricky, because a simple change can be incompatible. Well, we didn't invent that, luckily. There's a tool, an open source tool, which does that. It's called Buff. Buff does a lot of things, linting, compiling proto files, but it also has a tool or a plugin, not sure, but it also has a feature which detects breaking changes in all kinds of formats. So it detects changes in the generated source code, or it detects changes on the wire format, all these things. And we use that in our CI/CD pipelines, basically to detect if there are breaking changes, and if so, basically break the build. We just don't allow it. And this is an example of the output that you get if you make a breaking change. In this case, field number 1, header name test, and the name was the name was status, and I have renamed it to test. This is not allowed, so the pipeline breaks. The next one is linting. We're also quite strict on that. We also use a tool for that, which is the API linter from Google. Google have, for the cloud platform and for a couple of, actually a lot of their interfaces, they use gRPC. And they also lint that, and they're really opinionated, like Google is often with tools, on how what an API should look like. So they're really strict on naming, but also things like that every API needs to support pagination. Well, that has an impact on the amount of effort we need to put in, so that's a rule we disabled. But a lot of the rules we actually still have, so I think like 200 rules are still in the rule set for us. And it detects basically the error you made, also in naming. So for example, you shouldn't use the term status, but state. Well, they have a reason for that, but we basically adopted their code style for that. And that just works. Sometimes we don't agree. You can also ignore a rule, like you often do with linters. We also did it over here when we think we know better, which we of course do. So that's all like still pretty, maybe not basic, but I think most people agree that linting and checking for changes is pretty good. Then the thing that most people might not agree on is that we have one repository with all the APIs all stacked together. Instead of saying, okay, I have a microservices which exposes an API or a couple of APIs, and then I put my definitions over there. We put them all together. So why did we do that? One of them is just to have an overview. I don't want to go look in every repository and check, okay, what API are you exposing? What API are you exposing? And then making a mental model from that. It's all in one big overview. Another thing is that you can reuse messages. So let's say in our case, a stream is a very common entity we use. It's always the same thing. I don't want to repeat that all the time. So it's just in a separate directory in the same repository, and it can be reused. Not really 100% related to that central definition, but we are very strict on being API first. We have to, because it's separate from the code. So you can't even write code that compiles without this definition. So before you write any code, you have to think of an API. Like I think even when you use, or even, also when you use REST, you also do that, I guess, right? Most people at least. So we also do it, and it's mandatory because it's like, you can't do otherwise with this setup, which we think is a good practice to have. First think of the external form and then implement it. And because it's central, because we also have this breaking change detection, we require a mandatory review before merging, which is, I think, pretty standard, but it's really important for us because if I add a field now and I think like 2 minutes later after merging, like, oh shit, I want to rename this. Yeah, I can't because our breaking change detection will break. So we really want something to be pretty good before you merge it. And I think that actually, that creates a bottleneck, right? Before you can merge, you have to get the review. That's usually annoying. But most of the time, the review actually gives us good value. I mean, people sometimes make a comment saying like this whole thing is useless because we already have an API for that. Or you used the concept in a certain way that didn't make sense at all. So it really encourages discussion between people. So we are really happy with this approach. So having a central repository with quite some complicated pipelines now by now, quite a bit of logic. The question is, okay, we have proto files. How do we get these to our apps to actually use them in our code? One of the things is you can say, okay, let's distribute these proto files in some way, git clones or whatever you want to do. Or since everything is already central, why don't we just say, let's make a Maven artifact, let's make an NPM package, let's make a Python package, let's compile it all in one place and distribute these using the tools that you already use in Java or in Python or in Node. Well, based on this story, I think you can all guess that we chose for the second one, which some people think it's a bit of an anti-pattern, centrally generating code for an API and then distributing. I used to think that way, but for us, I think we didn't yet experience any errors or issues with that. So one last thing, or do you want to do this one? What does it look like, our central API definition? It is over here. So this is the project. It contains quite a bit of protos. And basically it has, each directory you can see like a resource in REST, something like that. Pretty much the same. And all the proto files are here. All together, all being linted together, checked together. All the stuff happens basically over here. From these protos, we generate code. All this code is over here. So we have 4 languages at this moment. For JVM, we have some custom Gradle stuff going on. For Python, we do something else because, well, Python works differently than Java and Gradle. TypeScript, something else. And for Go, it's basically completely different. So that's over there. I'm just scanning it a bit so you get an impression of what it looks like, how big it is, and stuff like that. Quite a lot of stuff goes into CI/CD and in compiling. And that brings me to Robin, I think. There you go.
All right, thank you, Jan-Kees. Then for me is moving on to a verdict. So let's first bring the positives here. So as you saw in the demo, gRPC is quite easy to use and it's quite easy to start, actually. There's great compatibility, and these compatibilities, it doesn't only stay within the language, but it also goes between the languages. It's very high performant. We haven't had any hiccups whatsoever in production, and we've been using it for over a year now. The cross-language code generation, Jan-Kees also showed you in the demo that he did. And it's opinionated, which was very nice for us when we started using gRPC, because we didn't know a lot at the beginning. And it was very nice that, for example, the Google API linter had a lot of rules that actually helped us to form our own opinion about a lot of stuff. Then the negatives. Well, opinionated can be too opinionated. This is a matter of preference, of course. We don't feel it's too opinionated, but at the beginning we had to disable a lot of linting rules because we just didn't agree, or we didn't feel the need yet to have pagination, for example, by default in all of our APIs. So it can be too opinionated in that sense. But of course, you have the control yourselves over there. Default values, I already told you guys, it bit us really quite sometimes. And you really have to think about that. But there are solutions for that, luckily. The generated code is quite verbose. You really don't read. When you're in your IDE and you're looking for the name of a specific field of a message, and you just can't remember it, and you decide to look in the code, then you abort that mission completely, and then you just take the proto files and look at them, and then you know what the field is named. So that can be, a bit cumbersome. The wire format, and this is specifically actually for web, is unreadable because binary is sent over the line. It's hard to debug from your Chrome DevTools. Actually, it renders them useless in that sense. So that can be hard to debug. But for us, the verdict is that the positives really outweigh the negatives, and it's production worthy, and it's just really, really fun to use. Development speed increased dramatically for us because the way we use OpenAPI was quite a hassle there. Well, Jan-Kees actually showed you the API definitions already, and we have an announcement to make here. Is that we open source the API definitions on GitHub, so feel free to check them out. Feel free to use them as an example for yourself. The API definitions include all the proto files that we have. The pipelines are still running on GitLab because we mainly use GitLab, but you can see the logic there in the GitLab CI. That also brings me to the last part. It's a mirror of our GitLab repository. We do have the ambition to actually move to GitHub Actions because we would prefer this actually to be fully on GitHub. That actually wraps up our talk. Thanks for joining. I hope you learned something, and I think there's some time left for questions.
Yes, we definitely have some time for questions, but first, round of applause. Guys, a really well built up tool, nice introduction, really good examples, really like the verdict, and a really nice present on the end as well. I have a small token of gratitude for you both as well.
Thank you very much.
A local brewery here in Utrecht. Hope you enjoyed with something to eat there as well. Yes, are there any questions from the audience at the moment? Ruud, please.
You mentioned that there are downsides when having to inspect in your browser, because the wire format is unreadable. Are there any browser plugins that can actually help with that?
Yes, there are. Do I need to repeat the question? Or?
Please,
Yeah.
if you can.
Yeah, the question is, are there any browser issues to prevent or to make the output in the DevTools readable? Yeah, there is one plugin I know. but it requires you to actually add some code to your application, which I don't really want to do. I didn't try it to, I don't know what the actual effect is of adding that code, so I didn't try it for now. But it's one plugin I do know of, but yeah.
Another way to actually solve it is to use JSON to gRPC transcoding. And that can be done, for example, with Envoy reverse proxy, which does a translation of JSON to gRPC. But that does require you to put quite some annotations in your proto definition specifying what the what the REST version would look like. But then you're back to REST. But that's actually what Google does, and you can check out their API definitions. They're at I think github.com/Google APIs, and there you can see those annotations.
Wouter.
So, JSON-based REST services are way more common than gRPC, I would say. What has been the response of your clients for your choice of gRPC?
Yeah, what are the responses of the clients? Because gRPC is being used way less than REST, you asked. None really, because we are our own client. So the clients of the API definition at this point is our own CLI, which is then used by a client. Our web console, which is also like the web interface, and then it's also just in the code, and all our internal apps. So I haven't heard of any client that actually directly talks with the API.
Maybe good to ask you an additional question then. I know you guys do some really sophisticated engineering at Stream Privacy. Actually, you showed us some of it. And maybe you can explain a little bit what Stream Privacy is and does. I know that you guys are giving presentations also in America, in Austin lately. And what is actually the product about? Maybe that gives a little bit of context.
Yeah. So what we build at Stream Privacy is a privacy-safe data processing platform. And this part that we covered over here are actually all of our orchestrating APIs. So setting up all kinds of resources that you can actually use to start sending data. And the clients that we use to send data, at the moment, that's the only part that we have REST still. But that is over HTTP2. Their REST is used, so people could still use the regular way. But like I just mentioned, the JSON to gRPC transcoding, that's actually also Google's approach over there. People can choose, do you want REST or do you want gRPC? And the server that they're actually running, or the application that they're running, that uses the gRPC implementation, and they have a proxy in front that does the transcoding. Does it answer your question?
Yeah.
Okay, great.
Regarding performance, maybe, we do use, as Robin said, basically for our management APIs, let's call it that, so not the high performance part. At least people don't create streams on with a very high load. They use the stream with a high load. So we didn't really see the performance benefits in production. I mean, it's quick, okay, good. We did some testing with it for my machine. It's a nice analogy, I think, or a nice anecdote. I was actually sitting in the waiting room at the hospital waiting for the doctor's appointment on my phone using phone tethering, using a VPN, let's see, to the Google Cloud then with telepresence. There's something more, I guess, but let's say a very bad connection, and I could easily go to 10,000 TPS on just my laptop. So it's blazing quick, and you don't have to do anything for it. So that's really nice, but we're not yet at that scale that it's important for us on this part of the application.
But the cool thing there, HTTP2 really helps there because you can multiplex there.
Yeah, probably HTTP2 does most of the performance part. Yeah.
Any other questions?
Yeah, so it was a remark by Roy van Rijn on the stream. Maybe also nice to share here for the audience about by stream. Maybe you can repeat, Roy?
Yeah, so you mentioned the by stream. I've seen a case where you have a server and client. The server is sending positional updates, the client could send back filter settings. For example, if you disable some types of ships in this case, then the stream would adjust. So this is a typical case where you could use Spice scripts for like one is sending information, the other sets filters and limits.
Yeah.
All
Not
right.
sure how to repeat it, but yeah, good one.
All right. I think we wrap it up. Thank you very much again. We take a small break of 10 minutes approximately, and hope to see you in the stream again in 10 minutes. And we'll have a drink here. See you in a few minutes. Thanks.
Thank you all.
Thank you.
Ladies and gentlemen, welcome back to the OpenValue meetup for our second talk this evening. We have Ali Meshkat here. Ali has been into Kotlin for quite some time. You've given many workshops at conferences, at different clients, and you've already also been part of a movement at Rabobank, where you, with others, introduced Kotlin and made stuff happen with Kotlin. And really curious to hear what adventures you had and how everything went and where you are right now. So please take it away.
Yes, thank you very much. Hello, everyone. Yeah, exactly that. We are going to talk about how we want to move to Kotlin within Rabobank. Well, Rabobank is a company that likes to experiment and investigate new technology. Well, some will stick and some won't, but that's typical. But Kotlin is definitely one that sticks. I'm going to share with you in coming hour my side of the story that Rabobank wants to move to Kotlin. Yeah, well, I'm Ali Meshkat. To unwind, I like to go to a forest somewhere. And well, if I'm not in a forest, I like to bake to relax and to slow down. I'm an avid Kotlin user. I've been using Kotlin since 2018. So yeah, and I also at that time I also started to teach Kotlin because well, I think the best way to learn something is to explain to other people, and that way you know what you're talking about. I'm with a company called OpenValue Rotterdam. And I'm a current assignment. I'm at Rabobank. I'm part of the Java Kotlin community, and I will speak more about that. Oh, that didn't want to go. Okay. So let's give you an overview. That's what happens when you edit your slides in a train on your way to here. Things go wrong. Although, to give you some overview of what I'm going to talk about, well, first I will try to give you some context where I'm at. And, well, what is Kotlin? Maybe not everyone knows what Kotlin is, so thought maybe it's good to spend some slides on that. And, of course, the main thing, the community, how we kickstarted it, and what is our mission, what did we achieve, what did we learn, and that kind of stuff. So, Rabobank is a multinational bank. Well, it is from origin an agricultural bank formed by farmers. It has business in lots of countries, and well, if you're from Netherlands, you know Rabobank. And the mission is grow a better world together. I'm basically I work for a digital platform, and digital platform works on the mobile app. And if you're with Rabobank, you know this overview page. We work with 6 teams on the features within the Bankier app, what we call it. So right. By the way, you can interrupt me at any moment to ask questions. So, really brief, what is Kotlin? Kotlin is a language on JVM, but it's multi-platform. It's developed by JetBrains, also company behind your favorite IDE, IntelliJ. Yeah, it is a statically typed language. It targets multi-platform. And it's also official language of Android. And I think the development started in 2011, and they released the first version in 2016, if I'm not mistaken. And in 2017, they get really big traction because, well, Google announced that Kotlin is the official language. And, well, that makes it really that things happen for Kotlin. So you might think, okay, nice, we have another JVM language. Why should you use Kotlin? Well, I can name a lot of reasons. Well, if you know from languages like Java, referencing a nullable reference, if you call a member on that, that will, well, cause a null pointer exception, and that's something that's common. So Kotlin has created a type system to take away that danger that comes with referencing nullable references. So they incorporate it basically in the type system. I think that's, for me at least, that's the biggest selling point if you want to use Kotlin. And also when you think about immutability, it promotes that. So that's also really great. Well, it is quite concise compared to Java. So Java, well, you have to write some boilerplate, and yeah, it makes your code less readable in some ways. So it also has paradigms like functional and object-oriented. Well, you have like objects, and you have functions that are first-class citizen. So what that means, functions of first-class citizen, means like functions are like classes, if you come from Java, and functions can be passed around to other functions returned, and you don't have to declare them specifically in a class. You can just declare them everywhere, and also you can assign them to variables, and you can also extend. So functions are really first-class citizens. If you want to do some functional programming, that can be handy. Well, something that is quite difficult, maybe in Java you need to use some library, that is asynchronous programming. Well, they are also baked that in the language. So you have coroutines. We saw that in a previous presentation a little bit. But that's a means to do some asynchronous programming and non-blocking, to write some non-blocking code. So that's also part of the language. So that makes it really great. So you don't need to learn another library to do some, to write some asynchronous code. The compiler is a little bit more helpful. It is, you can call it smart. So there are things like smart casting. So once you checked if the object's from certain type in the next line, well, you don't need to cast it to that type. You just it will understand that it's already been checked and everything is all right. So you can just call the members. So that's kind of great. And I think type inference is nowadays, you have it also in Java, but it's, I think, still on local scope. But the Kotlin, that's all, you can use it everywhere. So that's also kind of nice. What makes Kotlin different than Java is also, for example, it's much better with when you want to extend a different library, for example. don't need to write a lot of code for that. You just can use extension functions. So that makes it, that way you can also write more expressive code. And they already have some nice extension functions on top of existing libraries, like the collection library we all know. Or you might know if you come from Java, at least. And they also have multi-inheritance with delegates. So that's also something that doesn't come with Java. As I said previously, it's multi-platform. It targets like JVM native, so you can create Android iOS apps. I think that's also most people associate Kotlin with. But you can also write code in browser. I mean, that targets browser. So, well, you can write full stack Kotlin code. So I don't say you should do it, but that's possible. So hold your horses there. Well, if you want to write some nice libraries that are usable and easy to understand, you can create DSLs. Domain-specific language, that's what it stands for. And it's great. So you can write really intuitive libraries. Yeah, and of course the tooling support, which comes with JetBrains and IntelliJ. And most of all, it's pragmatic. It's meant to. It is pragmatic because it is also they don't hold to backwards compatibility that's strict. So if some things are obsolete, they don't hold it forever. They will eventually get rid of that feature. But that means well, some things will break eventually. But they have also a nice way of dealing that, so they don't hurt you that hard when you upgrade. Yeah. So as I said, we like at Rabobank we like to use the best tools, and I think Kotlin is also the best tool for the job because well, I'm quite lazy developer. I don't like to type that much. Well, if I want to be able to use features from other languages like Scala, C#, for example. So I think Kotlin incorporates that. They don't reinvent the wheel. Well, you don't necessarily well, have to go to Scala or to other languages if you want to use certain specific features. Because, well, when they designed Kotlin, they take a good look at other modern languages and learn from them. I think especially Scala was one of the most inspiration for Kotlin. And well, as a developer, I think it's important to write readable code that is easier to maintain by other developers. So also should be safe. You shouldn't be afraid that you, well, sometime runtime something can break, and that's also something I like about Kotlin. It's quite safe. It's also one of the in top 4 of one of the most loved languages. So it's not. It has a good reason. That's already been there for like a long time now. So yeah, let's have a look at the famous FizzBuzz. How does it look like for what does it look like for Kotlin code? Let's click this away. Oh, where's my mouse? So let's have a look at the code. Basically, it's obvious it's a FizzBuzz, and I think everyone knows FizzBuzz, but I will explain a little bit. Yeah, you see here you have a function called main, and that means that's the entry point of your application. Mostly in Java you have to write a class for that, but in Kotlin you can just define a function. here you define a range of numbers from 1 to 100. You can also do it in steps, but this is the simple variant. And here we will do something with the values that come through, and we will iterate through them. And here we do checks. So there are three conditions. And of course, the default condition is this, it's else. And here we check, well, is the number coming from the range, is it divisible by 5 and 3? Then we will return this value, and this visibus. And if it's divisible by 5, then it's bus, and if it's divisible by 3, it's this. Okay, so that eventually you will have a list of that, and we will print that. So that's basically the program. Quite simple. Let's see how fast JetBrains is today. This is a REPL from JetBrains. It's an online compiler, so I don't know how fast it goes. Oh, yeah, there we have. But well, let's focus a little bit more on what's inside of the visibus, and you will see it's quite expressive language. You have the when expression, what we call the when. It's similar to a switch, but it's expressive, and if a condition is met, it will return. Well, you have 3 conditions here, and if none of them are met, this will be returned. That's basically the number. And this when returns the well, these strings. And this will be accumulated and printed here. So it's quite concise, and yeah. Usually in Java you have streams and then map and a lot of things, a lot of boilerplate code to achieve that. And well, Kotlin is quite straightforward. So that makes it also easier to understand and easier. Oh, there's a question.
So the map function has when with 3 branches that return a string and
Yeah.
1 branch that returns a number.
Yes. But that's all right. It works.
Number to a string?
Yeah, I think so. Yeah.
Yeah.
But that's a good observation.
The type is a string. So this is string of strings.
Then I have to write more code, see if that's.
Well, in
that's
this case, it will return a string when it's the one of the first 3, and an integer when it's the else, because it was returning a unit, so it can be anything.
So it's a string of
I think it's a stream of any, so it can be both. Indeed, that's
And
correct.
The unit is what the main returns, but not the function inside.
Yes, exactly. The unit is. So this is the return type of the main. We can also leave it out. But the when indeed is of type any, the list that so we can also assign it, and it should be any. But then we have to return it, and I don't like that. You can also say here, fall. It's hard to type like this. And say the capital. I think this should be returned. Oh. Crash. Ooh.
Maybe this is also something to just try after the presentation. I didn't need to interrupt the flow.
Oh, no worries, no worries. Always good. But yeah, this is basic example. But it's a good observation of you. So, oh, did I miss anything? No, I didn't. All right. So let's talk about what I'm actually here for. basically, well, the talk about Kotlin movement, basically. So when I started at Rabobank, it was 3 years ago, and well, at that point, one of my goals was, okay, I have to use Kotlin because, well, I really like the language. But at that point, it wasn't possible because of some technicality with the tools we use at Rabobank. One of the security tools that scans the code for vulnerability didn't support that. Basically, that was the conclusion, and we couldn't use that. We couldn't, well, deploy code on production without proper checks. So, but still, I really like to share knowledge about Kotlin. So, well, I thought, okay, why not give trainings on Kotlin? Doesn't hurt anyone. But with that, I also create a little bit more awareness for Kotlin, but also got in touch with people. So that was also a really nice way of creating some network. So I came in touch with other people that had same ideas, and well, they found out that the tooling was upgraded. I think that was maybe a year later than I started. So they found out that the tooling was upgraded and we could use Kotlin in production. So for me, it was like, okay, nice. And they were already converting code. So they had this API. So it was like 1,000 much code they converted in one sprint to Kotlin. So that was basically proving to business, well, we can do it fast. And they also involved like management. So they pitched that idea. So yeah, I came in touch with the people and with the person that actually started that at his team. And well, he was also thinking about forming a community around Kotlin. So obviously I was really interested in that idea. And I thought, okay, well, let's do it. And but well, because Rabobank is quite a big company and you have a lot of communities, and well, we have already a Java community which is established and it has a lot of members. So we thought maybe we can work together on that. So because we share basically the same group of developers, we try to reach out to. So that's where our adventure started. And well, it is kind of weird if you want to say, okay, guys, we want to join your club and let's do it. That didn't work like that. So they come up with a lot of questions. And they were like, okay, asking really difficult questions and topics that all we had to look into. Like, okay, what about security? How secure is Kotlin? What is the performance impact of using Kotlin? So yeah, what does it mean if you what about when you want to roll out Kotlin within Rabobank, and well, how do we make sure that people don't make mistakes? So what are the pitfalls and are they documented somewhere? So you're like, okay, that's a lot of things we have to manage. So basically, that's, I think, the biggest hurdle you have to go through if you want to introduce something like that at a big organization. You have a lot of things you have to adhere to. And well, what we did is basically we pitched the ideas to different groups of people. Like we had architects, we had management, also business architects, and well, a lot of people that were really interested and they want to know about it. And yeah, that's basically the the thing we had to overcome to get our community. You cannot do that alone, and you need to have some people that are also interested in that idea, and obviously with different skill sets. Because, well, if you ask me to pitch that to a group of managers, I'm not the person that likes to do that, to be honest. So I need to have a person that's really skilled in that communication. So you have to have different type of people in your group. So that was the start of it. So we start having a group, and we start talking with different type of people, like with performance people. We had to come up with tooling that will scan the projects for performance issues. And same with the security. You have to extend the existing rule sets. And that's only the beginning, right? We haven't achieved nothing yet. And all the time we felt like, okay, this could happen. Oh. Wow. No. Oh. Okay. Yeah. But, well, it didn't happen, of course. Otherwise, I wasn't here. So we delivered everything they asked us, and we set things in motion. We had to also think about getting budgets for other people to work on things. So that's also something new. So I think that the clue is also get management behind you and get them, because they have to sign off things, right? They have to sign off budget and that kind of stuff. Important things. Well, I couldn't think of it when I started this with the other colleague of mine. So basically, along the way, we learned a lot of things about how it works in our organization to introduce a new technology. So it's quite a journey. And eventually, we were managed to reach our community. So now we have to do something. And we had the idea that people were really positive. They were really helping us out, giving us tips and tricks, and also helping with setting up things. So I think that was also really helpful. And we didn't have a lot of people that were, they were skeptical, but they were doing their jobs, basically. So that's nothing wrong with that. But they didn't really block us because blocking us. So we managed to establish a community. We moved in a bigger community, so that was great. And I think I can say Kotlin is officially supported by Rabobank. Maybe a bold statement, but well, we have people that really want to invest in that, invest in that idea. Giving us the means to achieve things. So I think the learnings are really important. Get out of your comfort zone. I think maybe that's a little bit broad, but I think that's the first thing you need to do. Also, make sure that you ask for help, because, well, you cannot do this alone. And you have to look for people that are talented in a way that can help you along the way. And you need to speak out sometimes otherwise you will not you want to steer certain things in a certain direction, and for that you need to speak up. So it's nice that we have this big pool of developers we can reach. What now? What do we do now? I mean, sit back and relax? I don't think so, because that's just the start. We have them. We assure them that they can use Kotlin, but that doesn't mean they are going to do it, because they have other things on their head, right? So after that, we had a kind of group of 4 people, and we thought, okay, what can we do to create more exposure for Kotlin? And I think the idea was, okay, we have to celebrate this, at least that we have this, we are part of this bigger group. So we achieved that, so that's nice. So we had one day event that was all about Kotlin, and we had internal speakers also, but also external speakers. And that way we also learned people that from outside were interested in what we were doing inside Rabobank. So they tried to help us with that. And of course, the next step is, well, we have to train people, right? Because, well, they heard from Kotlin most of the times, but still they will need to learn some basic stuff. So what we did was we came up with a training program to train them basically. So we had an introductory program for people that were just starting out with Kotlin, want to get their hands dirty on the syntax and the basic features. And we had also the advanced for people that were already using some Kotlin, but they want to learn how to write idiomatic code. Also important because Kotlin has other way of thinking than when you come from Java. So when you start out from Java using Kotlin, then what they also say you will write Java-ish Kotlin. It's a first step, but it's it will also create some technical debt that you have to fix later. Because in Java, in IntelliJ, you can also generate basically Kotlin code from Java. That's a great feature, but you will create a lot of technical debt. So that's why we want to have also advanced trainings for people that were already using Kotlin and want to use more idiomatic Kotlin. Also, things like asynchronous programming was one of the topics. So what we achieved there was, okay, we had a little bit of community growth. So we had more people that were using Kotlin, or at least starting to experiment with Kotlin. I think we had a highly rated training program, and also a steady increase in Kotlin projects. Yeah, maybe something that we learned, because previous time we didn't have a lot of data to go on. So we had to do things on intuition. And yeah, that's not always the best way of approaching things. And you need to have some feedback loop, right? You need to learn based on facts. So we did that this time. And because of that, we also improved our trainings program. And also something that was challenging is, how do you approach people online? I mean, yeah, it's nice that they are joining, but how are they really engaged and interactive? So that's also some challenge that we were thinking of when we were thinking of the trainings. So we had to come up with a mission. Yeah. Eventually, you have to come up with the idea where you want to go to. Right. I think mission is not hard. We want to increase Kotlin adoption, but in a sustainable way. So we don't want to push all through ourselves. We want to have people also involved. And one of our KPIs was, okay, we want to at least increase the count of Kotlin projects with 5%. Yeah. So now 10% of Kotlin counts 10% of Java projects within Rabobank. Java is still king, let's say that way. So
Is that within the Netherlands? Or
oh no, absolutely not. It's about Rabobank. So that would be really, really big.
I mean, like Rabobank is international, right? right?
Oh, right, right. That's a good point. Yeah, we have a lot of departments. I think we try to reach them all, and yeah, it is. I don't know if even because you have different branches, but that's a good question. But I'm not sure if you can even reach them, because they have, I think, different banking systems, and yeah. So I think to increase adaptation, you also need to increase the skill level of our engineers. So they get confident using Kotlin. Yeah, that's why we try to offer them a seamless trainings program. So for each entry level. Before we had only for beginners and advanced, but well, we have also a group that we didn't target, that people just starting out, but they have a little bit more experience, so they know the syntax, and so that's basically the a new part of the trainings program. And also different way of approaching and getting more people involved is, well, you can call them champions, pollinators, whatever. But basically people that come from different corners of bank that we can attract, of course, and get involved, and so they can help engineers within their own department with their Kotlin journey. Yes.
So is this change mostly driven by developers, or is this also something like solution architects suggest, or can you tell us something about that?
Well, shall I repeat the question? So the question is, okay, is it fully driven by engineers, developers, or are there other expertise involved, right? Something like that, architects. To be honest, I think from my perspective, it should go bottom up. So engineers first, and then well, the other people that are working with, like architects, business, PO, managers. So I think also what we try to achieve within Rabobank is create that engineering culture. So engineers first, basically. And I think managers are really supporting that idea. And well, there's always a discussion with someone from architects, but well, the team decides. Exactly. There are, yeah. But there are still architects that were really interested in Kotlin too. So thanks for the question. So I think, yeah, this is basically the end of this presentation. And well, the big giveaway is in the end we want to our engineers to use the best tool for the job, and that's basically it. In this case, it is Kotlin, of course, but it could be other things, right? It's not only keep you waiting. Yeah, so we want them to help them write software that's safe and maintainable, and also with tools that they love, right? Not something that someone told them to use. It should come from the engineers. So if I pique your interest about this idea, about the way of working within Rabobank, and and you feel like you want to join the cause, for example, Kotlin movement, well, please scan this QR code and you can find job offerings. Thank you.
Thank you, Nice things to drink and to eat for you as well.
Yeah.
So really nice to hear how you set up like a grassroots movement and how engineers basically evangelized a new language and how that is being picked up at the moment. I don't know if there are any questions at this moment. Guido?
Yeah, so my question is, I can see how you can convince developers to go to Kotlin because it's shiny, it's fancy, it's all and things. But can you give an example of you convince manager, or maybe the most serious one?
Yeah, it's a good question. We come up usually with numbers. So how much code reduction and how fast their time to market. That's usually the case with the pitches. We come with a lot of numbers, and I think, well, job satisfactory is also one of the points. Yeah.
Should management actually be involved in making decisions of using Kotlin over Java? I mean, do they actually know what they're deciding about?
Yeah. I think that's also a fair question. I think not. Not to be blunt regarding managers, but I think they have to be informed.
Yeah, sure. Yeah.
I think that's the main thing. And also, if you inform them in a way that they understand, they can support you. I think in that way they can help you. It's not like they will hold you back. Sometimes you need to have more resources, and that's
it's also, I would say, it's not a scientific discussion whether one language is better than the other one.
Yeah.
It's a really nice topic to talk over beers, for instance, especially if it comes to Java versus Kotlin. I mean, you could also make a case that Java is adapting the really cool features of Kotlin really fast with the latest versions that are coming out right now.
Yeah.
So how do you see that? Would you say the business case for Kotlin is getting less strong if you compare it to Java, because Java is evolving quite fast and picking up cool stuff from Kotlin?
Yeah.
How would you respond?
I think it's also a really good question, because you have the Project Loom coming up, because the code is from Kotlin, they're kind of nice, right? But what they call it?
Fibers?
Yeah, sorry?
Fibers,
yes. They have different names, but they're still in development. But that's the thing with Java. There are still a lot of things are still in development and are not fully there. But with Kotlin, you can already use it. And what happens on JVM, you can also use Kotlin. So you don't lose anything. I think that's the clue. You don't lose anything. You don't have to go back and use Java. You can still go on using Kotlin.
I'm sure we can talk a lot more about this. I don't know if there are any other questions at this moment for Ali. Yes, please.
Just a quick one. What is the adaptation time for someone who knows Java to adopt to using Kotlin?
Yeah, so the question is how fast can someone, like the learning curve for a Java developer to become Kotlin developer? That's a good question. So it depends on the developer, of course. So it's really, but I think you can. Well, the thing is with Kotlin, you don't need to learn the whole. You don't need to learn a whole new ecosystem. Like you don't need to learn all the libraries and all the frameworks. You just need to learn the syntax, and that's the big difference. So you can really start out with using everything you know already. Like Spring Boot, you can still use Spring Boot. So that way you can really start out pretty fast. And also something that I didn't mention, so you can move from Kotlin from Java to Kotlin in steps. So you can start out with real small parts. You don't need to do a big bang. I think that way you can also, yes.
I think that's also a big advantage to mention to POs or managers that don't want to invest the time to redesign. Where like if you pick like an entire new language, you want to redesign all your services, it takes a lot of time because it's a big bang, right? And here you can very gradually go over.
Yeah, you're part of the same ecosystem.
Exactly.
Use the same library, same IDE, same frameworks.
Exactly.
Yeah.
Yeah. So that's also really good point. It's a really good selling point, and I think we do that also in the presentations. So it's really you can reuse a lot of things, and you just need to learn new language syntax. Yeah.
All right. Let's wrap it up. I hope you enjoyed the meetup just as much as I did. For the people online, hope you enjoyed it there as well. We're gonna have some drinks over here. If you wanna enjoy that, better be here next time. So thank you everybody, and that's it.